All right, welcome to section 4.4. We're going to have two parts, part one and part two. In part one, we're going to look at what makes something a reciprocal. All right, so we're going to find the reciprocal of a rational number. If you never heard that word rational number before, rational numbers are numbers like 1 divided by 10, which is 0.1. It's decimals that end, or decimals that have a pattern, all right? Decimals that go on forever and ever and ever and ever and don't have any pattern, those are irrational. So we're going to be working with rational numbers and reciprocals, all right? So you know something is a reciprocal when if you multiply the two reciprocals, two numbers are reciprocals of each other if their product equals 1. So is 10 a reciprocal of 0.1? Now remember the 0.1 is 1 over 10. All right? So are these reciprocals? Yes, 10 times 0.1 is 1. So yes, they're reciprocal. 1.25, that's 1/4. And 4 is the same as saying 4 divided by 1. 4 divided by 1 is 4. So these two are reciprocals of each other, flip versions of each other, because when you multiply them, you get 1. So when you multiply two numbers, if it equals 1, yes, they are reciprocals of each other. Now if you look here, I have negative 1/2, and then I have, negative 2 over 1 and 1/2. One's negative, one's positive. No, these are not reciprocals of each other. This because it equals negative 1, not 1. All right? So it has to equal, when you multiply them from each other, they have to equal they have to equal 1. All right? In this case, if I multiply it, I get negative 4. That's not a reciprocal of each other. 3/4 and 4/3, yes. When you multiply those two together, we get 1. 1/8 and 8 over 1, or 8, that equals 1. Yes, these are reciprocals of each other when we multiply. So 2/3 times negative 1.5. No, because when you multiply 2/3 and negative 1.5, you get negative 1. To be a reciprocal, you have to multiply them and they have to equal positive 1. All right, so all of these right here, 1 over 9 and negative 9, well, right off the bat, one's positive, one's negative. You know that these are not going to be reciprocals of each other. All right, they have to be positive 1. All right, so to find the reciprocal of a fraction, you essentially are just going to flip it. All right, and then invert the number, numerator and denominator. So you're just going to flip what you have. So to find the reciprocal of 3/4, you just flip it, and you get 4 over 3. And we can check that. 3/4 times 4/3 equals 1. Reciprocal of 7/8 is 8 over 7. We can check that. 7 over 8 times 8 over 7 equals 1. Let's find the reciprocal of 9 over 2. You just flip it. 2 over 9. And to check it, 9 over 2, 2 over 9, it cancels out to 1. They multiply to equal 1. They're reciprocals of each other. So if 13's at the top, 13's going to be at the bottom now. 7's in the denominator, so now we're going to put 7 in the numerator. Right? So just flip it. The reciprocal of a fraction is just its flip version. So now I can check that. 13 over 7 times 7 over 13. All right, when I multiply those two together, I get 1. All right, so 1 over 10 is going to be 10 over 1. All right, when I multiply those together, I get 1. So 1 over 10, 10 over 1, that equals 1. All right, over here, if you look at it too, that also is a decimal. 10 over 1 is the same as saying 10, right? Negative 1 over 6. So 6 over negative 1, that's the same as saying negative 6. All right, so when I check those, negative 1 over 6 times 6 over negative 1, when I multiply these, a negative times a negative will give me a positive 1. All right, I'm going to flip this version, 7 over negative 6. I'm going to flip it, right? And that's the same as saying a decimal. All right, so 7 divided by 6 is 1.66, 1.166666, repeating. All right, a negative 2 times this positive divided by that negative, it's still going to be negative, all right? But when I multiply these two to check them out, negative 6 over 7 and 7 over negative 6, when I multiply those, a negative times a negative, there's my positive 1. All right? 6 times 7, 42. 7 times 6, 42. 42 divided by 42 is going to be 1. All right? So we can use our calculator to do some of these fractions. If you want to remember here, you hit alpha, y equals. So you hit that green button, y equals, and then you'll get your n over d, numerator over denominator. And you can type your fractions in that way if you'd like. Negative 6 over 7 times alpha y equals, numerator over denominator, 7 over negative 6. And there we get our 1. All right, so if you need to watch that again, alpha y equals is how you can put the fractions in the calculator. All right, just rewind, pause as you need, okay? This is a rational number right here. This is rational because it repeats. All right, so this is a rational number because we got 1.1666666. If it repeats or it just stops, like 0.1, 0.25, those stop. They don't repeat on in forever and ever with no pattern. Then they're rational. So when they have a pattern and they stop, they're rational. It makes sense. When they go on forever and ever, no pattern, we call those irrational. Here's an example of an irrational number. If I hit my second pi, 3.141592654, and it goes on and on and on even after that, that's an irrational number. All right, no pattern, no logic to it, just goes on and on. All right, we'll talk about pi March 14th. All right. So go ahead and make sure you have that written down before we move on. Pause if you need to. All right, any number that can be written as a fraction is called a rational number. All rational numbers have reciprocals except for a 0. If you can write it as a fraction, it has a reciprocal. So 2 is a rational number. 2 as a fraction is 2 over 1. All right, so 2 is my whole number. I can turn it into a fraction because 2 divided by 1 is still just 2. Its reciprocal is 1 over 2. And the reason why 1/2 is the reciprocal of 2 over 1 is because 1 divided by 2 times 2 over 1, well, 1/2 times 2 over 1 equals 1. So when you multiply by its flipped version, if you get 1, you know it's a reciprocal for sure. All right? So now, pause it if you need to, rewind it if you need to. Now we're going to start looking at part 2 of this, all right? How to use the reciprocals to solve for x, okay? Before, I would have this right here, be leave me alone divided by 10, right? That's what we did in the past unit. Well, what's the opposite of divide by 10? Multiply by 10. Whatever you do to one side, gotta do to the other, right? Great. So now I get the 10s cancel out. X equals 2 times 10 is 20, right? And then over here, leave me alone divided by negative 7. The opposite of divide by negative 7, you're right, times. Whatever you do to one side, you have to do to the other. Watch your signs. These 7s cancel out, leaving me with y equals negative times a negative is a positive. 3 times 7 is 21. All right, z is leave me alone divided by 8. The opposite divide by 8 is multiply. Whatever you do to one side, got to do to the other. The 8's cancel out, left with z equals negative times the positive, and the signs are different. It's negative. 4 times 8, 32. All right? So, for this new stuff, I'm going to create a second video, part 2. Go on Schoology, click it, and we'll start right here. All right? Thanks.